Hi, how are you? How is everyone? Sorry about the delay to start this webcast. This is the first webcast of a series of 26 webcasts for all Latin America and New Zealand. This is presented by LAOUC and New Zealand Oracle User Group. It's my honor to present Mr. Arup Nanda with his presentation about how to secure your database in one day. It's not that much what I can talk about Mr. Arup Nanda. Everybody know him. He's basically a celebrity in the Oracle world, and he is a fellow ACE director, and I hope everyone enjoyed the presentation. Thank you so much. I'm going to give now the control to Mr. Arup. Thank you.
Francisco, that was a wonderful introduction, very flattering. Good morning, good afternoon, or good evening, wherever you are. Buenos dias, buenas tardes, and buenas noches, señoras and señores. Thank you for inviting me. I am from New York, in the U.S. I don't know exactly where you are from. In Latin America, you are pretty much in my time zone. But if you are in New Zealand, you are 16 hours ahead of me. So, with that being said, let's start with today's topic. Since this is the first time we're doing a webcast for Latin America, I will ask you if there's a problem or something, please speak up in the chat window. So Francisco, I'll be watching the chat window all the time. If you see a problem or hear a problem, by all means, go to the chat window or speak up so I can hear. I tend to go a little bit fast, but please let me know if I go too fast. All right, let's go on to the next one. A little bit about me. I think my biggest qualification is that I have been an Oracle DBA for the last 16 years. I'm still an Oracle DBA, like most of you probably. I speak at many conferences, including Oracle Open World. I've written articles, and I've written about 4 books, and I provide trainings and security audits. I brought up the global database group at Starwood House in White Plains, New York, and I write a blog, although not so regularly, but I try to get in as much as possible in Oracle. And my blog is arup.blogspot.com. What I'll be talking about today with the scripts, they'll be available in my blog as well, so if you can always download them. What we talk about today? Security is often a misunderstood topic. It's very misunderstood, and a lot of myths or mythos. For example, people sometimes say, well, you have to have encryption. Without encryption, it's not secure. Well, that's a myth or a mytho. It's impossible to say that encryption is going to solve the security problem, and you will understand why. Other things are pretty interesting. One you can see here, don't use the port 1521 for the listener. Again, this is something most of the auditing companies come in and they tell you that if you're using the port 1521, it's not secure, and if you use a different port, let's say 8886 or 8855 or something, that is more secure. Again, it's a myth in the security compliance. It's going to attend 60% of it, and you spend what? How much? It's about 1 day in this. The recommendation has the pros, cons, and impact, which I think I will talk about today. We have that. And then all the scripts, you don't have to write down at all from the screen. You can download all the scripts from my blog, and I actually put the thing here, so you can just download that from there directly. Let's go to that, the preliminaries. Of course, the physical security is very important. You have to access control, get the control access to the server itself. You have to authenticate securely, have Unix user ID, password, etc., and all that. But OS-specific vulnerabilities, for example, the patches, including the listener, you see exactly what kind of problems they have and how exactly you solve the problems, and database vulnerabilities. But finally, the security principle also relies on one thing. If you know that you're being recorded, that your access is being recorded by a video camera, you are less likely to commit a crime. The same thing goes for any crime. If people know that access are being recorded somewhere, they are less likely to commit a crime, like a data theft or update or something. That auditing actually comes into picture, and that's exactly we'll see how we can do a basic rudimentary auditing to comply very quickly. Let's say the first one, protecting the Oracle account. How do you protect it? First, we say that this is the again trick. You can institute an indirect login policy. That means you have an Oracle software, let's say called Oracle. Oracle software account owner cannot be allowed to log in directly as Oracle. So if I want to log in as Oracle, I have to first log in as myself, as J. Smith, for example. Then I give the command like this, su -u Oracle SYSDBA. What does it accomplish? What it accomplishes is that sudo commands are actually given as a different user, and they are recorded. So every time a sudo command like this is given, a record is maintained that the user called J.S. Smith actually gave a command like Oracle, SYSDBA. As a result, every action by J. Smith, every action that actually used the Oracle software, the Oracle software, Oracle account owner, is recorded. So, how do they protect the Oracle account? It protects, because remember, when people know they're being recorded, they tend to commit less crime. So, DBAs or anybody who actually does anything like that, now they know that the sudo access is being recorded somewhere. They don't have access to that. They can't delete it. They can't remove it or alter it. So they cannot. They will be more careful in what they do as opposed to not protecting it all. This is also a requirement for most of the compliance things like PCI, Safe Harbor, and other countries as well. Let's go to the next one. Listener information. Information from listener. What can you get from listener? If you use listener control, you can use the word services, the command called services, and you can draw more. It gives you a lot of information which is about the listener, including the machine the listener runs on, the port number it runs on, the what user ID it gives, executable executes, and all that, which are very important for a hacker. Because if hacker knows what kind of machine you are running, what OS you are running, what OS version you are running, he can, once he gets all that, he can probably target that attack to your system. So how do you protect it? So to do that, first let me ask you a quiz, although you really can't answer the quiz, but I'll just quote here. You must be logged in into the system where the listener is running to manage the listener. Is that true or false? That means you have a listener running on a machine called S1, and I don't have access to the machine called S1. I have access to a machine called S2. Can I manage the listener on S1 from the machine S2? I have no Oracle access on that server. Answer. You'll be surprised. Answer is yes, I can do that. How does it do that? Very simple. I start up listener control on the machine I can control, which is S2, listener control. Then I have to use this word, set current underscore listener, the IP address of the listener I want to control, which is an S1. Remember, I can install this on my laptop. I can download Oracle software. Once I install Oracle software, Oracle server, I have listener control prompt. Listener control prompt comes in. I say set current listener, the production database access IP address directly. Once I do that, I'm effectively controlling the listener on the production database server, not on my laptop. And it's true. Try yourself. You can find out yourself as well. So it's a huge problem. So once I have a listener, I can control the listener. I can do a simple thing like set raw mode on. I can use services. I can see everything about that machine directly. How does it connect that? How does it know to get the information? What it does is, it connects to the listener port anyway, which is let's say 1521 or 1526, you might have configured that. And you have to open that because clients will connect through that port. So you have to open that. There's no option to close it down. So this listener control actually connects using the same listener port and gets information from the listener. Huge security hole. What else can I do? Well, once I go to listener control prompt, I can say stop. Well, this will shut down. That will not shut down the database, but guess what? After the listener shuts down, there's nothing else anybody can do anyway. So it's like a denial of service attack. Then what I can do, I can say let's set startup wait time 20. What it does is, if I give the startup command next time, it has to wait for 20 seconds. So after I do a start command, the DBA in charge says, this is interesting. Somebody actually, the listener is down. So the DBA might think, well, this is something wrong with the listener probably happened. Well, let me start it up. But when it starts it up, it won't start immediately because the startup wait time is 20 seconds. So this is a problem. So it's going to stop, and the startup time, wait time 20 seconds, they'll go back and forth. And by the time it starts again, the attacker will go and say, put the stop command all the time. So the listener will never start. So we can also, the attacker can also put in a loop, so without being directly connected, he or she can actually continue doing this process by some kind of automated shell script without even going to the server, which is a huge problem, as you can see. So how do you protect? Actually worse. Listener control can do this way, can set log file. This is a command, a set log file command is used to actually set the listener log file to go to a specific log file name. In this case, it's called dump. So in this case, the command creates a file called dump.log. Then the listener control can also put set log directory as any directory in the server. Remember, this is not my laptop. This is the one I'm running on the production server. So as long as I put a valid directory name in the log directory command, I have that /tmp, for example, is a valid directory command. So the log file will be created over there. Now, can you see a big problem here? Let's say you have put your online redo log files in some certain directory, and those those files are, let's say, called redo01a.log, redo01b.log, and so on and so forth. The attacker can go and say, set log file, redo01a.log, and set log directory is the log directory for the online log file directory name. Guess what? Now it's going to overwrite your online redo log files. When it does that, what will happen? Your database, well, if it is not in a current log file, then nothing is going to happen. The database will continue happening. But when it goes to the log file, it will eventually go to the log file got corrupted, it will crash. What if it's a current log file? It's not archived yet. So if it's a current log file, the database will immediately crash because of the problem. But when you try to recover it, it won't be able to recover because the online log file is gone. So you have to do something called a point-in-time recovery. Not only has an outage, now I have lost data. So it's a huge problem. So what do you take away from here? Well, obviously, you don't want anybody to be able to control the listener using this command. That's the first thing. But as a secondary tip also, do not use the log file. So do not use the word, the .log in this because because they use the word like redo. Say redo one.redo, redo 2.2redo, and so on and so forth. I never use the word .log as redo. Not only that, the .log also may mean something else like a real log file. So somebody might just do a find command, find 5 days worth of log files and remove them. So somebody can do that. So in this case, that protects it from there. Anyway, so let's go back to thinking, how do I prevent it from happening? How do you prevent it? It's actually very simple. All you do is that you disable the online modification. And to do that, you simply put a very simple parameter, admin restrictions underscore the listener name equal to on. If it is by default, the listener name is typically listener, so you put admin restrictions underscore listener equal to on. And that's it. Once you do that, you will force list. By the way, it's listener Aura, so you have to recycle the listener. When there is actually you don't have to recycle it, you just say reload. Reload is actually something that's recycled, but there's no stopping and starting, and there's no interruption in between. Once you do that, nobody will be allowed to change using the set command earlier. Then how does it help really? If nobody is allowed to change using the set command earlier, as we saw here, nobody can do the set log file or set log directory because Oracle will reject it. The listener control will reject it, saying that the online modification is not allowed. Well, in that case, how do you modify something as a SYSDBA? Very simple. You have to log into the box directly, and you modify the listener Aura file, and then you reload the listener. And obviously, and that is probably more secure than somebody come outside. So once you have a DBA logging in there and opening the file and modifying something, obviously that's much, much more secure compared to this one. Second thing, you can also do something called a password. This is something that's applicable to Oracle 9i onwards. Oracle 10G, by default, the Oracle user itself doesn't require a password, but everybody else does. In this case, just put a change password and say config. It puts a password there. How does it protect it? Well, two things. In Oracle 10G, you can also disable that with the default Oracle user being able to log in without a password by using this undocumented parameter called local OS authentication equal to off. In that case, everybody will need a password to update the listener. There's nothing, nobody, including the Oracle software owner itself, which might be a slightly better prevention. If you do that, you have to be careful about one thing. Password is required for all the key listener operation, but not to startup. So startup is fine, you can do a password. But if you shut down, modify something, reload, you need a password. As a result, what happens is Enterprise Manager Grid Control won't be able to detect the listener output and do anything with it. So it will report the listener as offline. How do you solve it? Very simple. You create the listener using Grid Control directly. Oracle Real Application Cluster, which is a rack cluster where it doesn't know the password, so it will report the listeners offline. So, well, if it is in 10G, if you don't put a password, nothing will happen. But if you put in 10G, if you disable that command using the parameter I showed earlier, and you put the password, then rack will report as offline. But that's why you may not want to do that in rack environment. How does it really prevent it? Most of the listener vulnerabilities actually are two types: buffer overflow and privilege escalation. What you do is that what it means by that is when most of the attacker is send a packet to the listener. Remember, listener is nothing but it's a process that is waiting for some command to come from the client. And the command, it doesn't know if it's a regular client or is some kind of a spoof of application that is spoofing at the client. So it gets a command and executes the command. If the command goes over than the value it's allocated for, that's what is called buffer overflow. In that case, listener shuts down, creating a denial of service attack. The second one is called privilege escalation. That means sometimes people send a command, the listener will actually create a connection to the database server, the database directly, and open the connection as the Oracle owner. And guess what? If you use the Oracle owner, at that time, it can connect as SYSDBA. That's called privilege escalation. So there are two different problems in this vulnerabilities. But guess what? If you allow the listener if you disallow the listener to accept the commands online, and the only way you can modify the listener is by reloading the listener to the ORA file directly, then this kind of situation will never happen. That means nobody will be able to send a command directly, and then that command will be executed to create a buffer overflow of privilege escalation. And as a result, you will not prevent all the different vulnerabilities, but will be able to seal and protect against most of the vulnerabilities as a result of the buffer overflow and privilege escalation attacks. Let's go to the next one. So now brings up an interesting question. SYSDBA. Well, we have all done that. How do you normally connect a sys? You generally do this way, SYSDBA plus as SYSDBA. Or you can do SYSDBA plus sys, the / the password of sys as SYSDBA. Which one do you generally use? Well, I have to be frank with you. I am lazy. I don't usually type the sys password. I always do SYSDBA plus as SYSDBA because it's so convenient to handle that. But here's the problem though. What if somebody, through a privilege escalation or something, connects to the Oracle database server and somehow gets the ID of Oracle? And that, or for the matter, any DBA group owner. What will happen is that person can give the command, the first command, SYSDBA plus as SYSDBA, and then can become sys, period, which is a big problem. So how can you make sure that everybody who connects a sys must give a password? Because by doing so, even if a hacker comes in and becomes an Oracle owner somehow and then try to connect to the SYSDBA, will not be able to find out the sys password. So if you have hidden the sys password from the hacker cannot really do anything without the sys password. But how do you make sure that the hacker cannot log in without the sys password? Very simple. All you do is put in a file called sqlnet.ora file this parameter, SQLnet.authentication services equal to none. Once you put that, then nobody will be able to connect as SQL Plus or SYSDBA. You have to give the sys password. That means SQL Plus sys / the sys password as SYSDBA. So what's the ramification for this one? Well, the problem is, once you do that, nobody can be able to escalate the privilege and become the Oracle owner and connect as sys. So even if they can connect to as Oracle software owner somehow using privilege escalation, they can't connect as sys and nothing can be done about it. But you might be a little inconvenienced as a result of this because you have to now remember the sys password and you have to give the sys password all the time. So there's a little trade-off. But as a result of that, you will seal that vulnerabilities. Remember, you are not eliminating any vulnerability. You are actually trying to reduce it. So these are the little things you can do to reduce it. Again, I'm talking about everything you can do in one day. So it's not a humongous effort. But by doing so, the impact is significant. The permission issues, another one. We all know, if you don't know this one, go and check in your Oracle home/bin directory. You'll find an executable file called Oracle, O-R-A-C-L-E. What does the file do? Well, that's the executable file for the Oracle kernel. That's it. So if you do ls-l, you'll find that. Now this is interesting. You can see the first one there. The first character is a hyphen. That means the type of the file, which is the file. So that's why it's a hyphen. If this is a directory, you will see a D there. And the next three letters, RWS, they actually stand for the owner. What does this mean? And the next one is group, and the next one is others. That probably we all know that. The first one is that in this case, RWS. Obviously, the first one we know is read. Well, owner is able to read it. The W means that owner is able to write to the file. Actually, that means I'll delete the file as well. And the last one is S. Look at the next one, the group one. Again, R. There is no W. That means the group cannot write to the file, cannot remove the file, can't delete it, can't update it, can't do anything about it. But it can S. What does S mean? Let's look at the third one, the other. Can't read, can't write. There's hyphen. The last one is X. That is executed. Well, this is interesting. So what does S stand for then? S stands for set UID. Is that a problem? A huge problem. Let's see why. Let's first understand why that S is required. Why not X? X stands for a very simple thing, execute. Execute. So why S? And you might be also wondering another thing. Well, this is owned by Oracle, right? And when you start Oracle, you are a part of the DBA group. So in that case, actually you had become just Oracle itself. So you're not even a part of the DBA group. It can be just simple Oracle. In that case, why would anybody want the X for the others and execute privileges for the group? To answer the question, we have to understand how exactly Oracle really works. So let's say I have a Unix user called Ananda. Ananda gives a command SQL plus Scott Tiger. What exactly happens? To understand that, Oracle has something called a two-task architecture. That's important to understand because that's how you will do it. Let's see how the architecture really works. So here, Ananda uses a command called SQL plus. Oracle, in this case, doesn't allow SQL plus to connect to the database directly. Well, why not? If the connection is allowed, it could potentially do a lot of damage. So that's why SQL plus is never allowed to connect to the database. Instead, Oracle creates another process for it. It's called a server process. The server process is the one that actually communicates the database files and everything. The SQL plus command sends the information it wants to a server process. The server process gets everything from the database files and in turn sends it to SQL plus. That's a problem then. Remember, the server process has to act on behalf of SQL plus, but the server process must read from the file. Remember, it's not the DB writer that reads from the file. It's the server process that reads from the file, not the DB writer. The writer writes the file, never reads from the file. So, what will happen then? If in that case, if the Oracle software owner is not given an execute privilege by the server process, there is no way the process can read from the database files. And that's the problem. If we give that write privilege to the database file, to anybody and everybody, that becomes a serious problem because then anybody can execute that. So to prevent that from happening, what Oracle does is something called S, that means set user ID. That means anybody is allowed to execute the Oracle executable as the Oracle user. So let me repeat that. Anybody, including J. Smith, including Ananda, anybody which is not a part of the DBA group or anybody for the matter, will be able to execute the Oracle software not directly, but indirectly as the Oracle owner. That's the set user ID is designed for. So what's the problem? The problem is, let's look at this how it works, server process. So first, Ananda says SQL plus Scott Tiger. If you do a PS1 AEF grep for SQL plus there, you'll see that's a process like this. This is the client process. This is not the server process. Look at the process ID there, 6339. If you do a PS1 AEF grep for 6339, you'll see another process there. That's called the server process, the 6340. This server process is the one that communicates to the database directly. Now, look at this server process here. Look at the whole line there. Protocol is equal to BEQ. That stands for Bequeath Connection. Bequeath Connection actually connects to the database server directly on the server itself. It doesn't go across the network. It doesn't go through the listener process. That's one of the reasons why this is why we need to have an execute privilege over here. As you saw in this case, the execute privilege from the Oracle executable, because the Bequeath connection requires to execute that Oracle process. That's why it needs it. But what's the problem with that? The problem with that is anybody can execute the Oracle executable, and by sending it malicious commands, sending it wrongly executable commands, it can bring down the system completely. Huge vulnerability. In fact, that is one of the primary sources of attack for most of the hackers, to actually send commands which the Oracle executable doesn't know that they're actually harmful. So it instead executes it and it gets away with it. And that's what most of the problems will come from. There's also the same avenue is used for escalation of attacks and all that. So how can you prevent it? It's very simple. What if you remove that privilege by anybody except the Oracle owner to execute the executable? Boom. The problem is solved. How do you do that? It's very simple. chmod, that's in chmod, 0700 Oracle executable. 700 means nobody, including the group, is allowed to do anything. No read, no write, no execute. Only the Oracle software owner can do a read, write, and execute. As a result, nobody else can do anything about it. This is how the new permissions look like, RWX, not RWSX, which is important. What does S mean? That means nobody will be allowed to also execute the Oracle executable as an Oracle owner. Can do that too. So it will be a problem in that case. Command in the server, SQL plus Scott Tiger, you will get an error right away. TNS permission denied. Sounds interesting, doesn't it? So before, because Scott Tiger gave it, everything is okay, you can connect to the SQL plus. In this case, after you change the permissions, suddenly got the TNS permission denied. Do you see the connections here? The connection is very simple. When you put SQL plus Scott Tiger, it cannot execute the Oracle executable to create a connection. So then how do you do it? How do you do otherwise? Very simple. So what you have to connect to the listener, just like a typical outside connection coming to the database server. So if you, for the outside connections, nothing will change, but they anyway connect to the listener. For the connections coming from the inside the server itself, you have to put an entry in the TNS Aurora file, and you have to connect not a SQL plus Scott Tiger, but SQL plus Scott Tiger at ProDB1 or something connection name there you put there. So now you have to use a connection, the connect string after every SQL plus connection, or for the matter, all Oracle connections. But by doing so, you are going through the listener route, and you are never allowed to connect to the Oracle executable directly. Just by this little fix, you will eliminate about 90% of the attacks that come through the Oracle executable. And boom, that's it. By simple fix, but you will eliminate about 90% of the attacks. All right, what else you can do? Very simple thing. Separate the client Oracle home. Most Oracle installations actually have only simply Oracle database and nothing else runs there. Sometimes you may want to run another application on the same box itself. For example, if you have a data warehouse box, you may want to run Informatica on the same box. You don't have a good idea, but suppose you do. Or sometimes you run the application and the database in the same box itself. Most often, people don't realize that they can actually create multiple Oracle homes. And you should create multiple Oracle homes in this case. The one Oracle home for the database, and that's it. Nothing but the database. Another Oracle home under a different Oracle user ID. Let's call that Oracle Client or something. And then that's completely different Oracle home. And that, in this example, actually, U01 app Oracle 11.1 client 1. Let's say that's a client home. That is different, owned by a different Oracle user called Oracle Client, as opposed to OracleDB. How does it help? Very simple. Go and check your Oracle home right now. You'll see Oracle home actually has a lot of execute permissions for outsider. In the group user, group other, you'll see an X for others. Why? Because executables like SQL class, SQL loader, TNS ping, and all those things, they're actually used by the client as well. Because if you have a client and you haven't separated the user ID, you have to use them. And that's the problem. That's exactly where the problem happens. Once you allow people to execute the executables inside the Oracle home used by the database, you have a vulnerability right there. You actually, it's like you're creating a huge wall around your house, but you have kept open the door all the time because people have to come in there all the time, even though they are not supposed to go anywhere else. They might not. They might actually throw some payload at it, which is actually a malicious payload. So how do you solve it? Very simple. Create a different Oracle home for the clients and let the client use that Oracle home. The DB Oracle homes will be different, owned by a different owner, and nobody else should know about that password except you, and remove all the permissions from others. This will be only by the other one. And that's it. That should be very simple. And doing so, you will actually eliminate most of the problems as well. Backup executables. If you go to Oracle Home right now, do this thing, ls-l *0 *O. This whether this is O, this is not 0. The first one is 0, the next one is O. You'll see there are a bunch of files with a name like Oracle uppercase O, listener control 0, and all that. What are those files? Those are the files that you then get created when Oracle is first installed. When you relink Oracle, let's say you apply a patch, let's say you apply a patch key or you upgrade and all that. When that happens, Oracle makes a copy of it, the first one. Then it then compiles everything and creates the final executable. If the compilation fails for whatever reason, it takes the backup copy and makes it the permanent copy. That's how it prevents it from something accidentally not happening correctly. Without this backup, something would have happened. Let's say during the compilation process, something got aborted in the middle, or the compilation gave an error. Guess what? Now you are out of an executable called Oracle, or TNS listener, or SQL loader, all the files. It's a problem. So that's why Oracle makes a copy of it. So what's the problem? The problem is, as you can see here, it's nothing but a copy of the existing Oracle. So you have protected your Oracle executable, the listener control executable, and all that thing, but you have forgotten there are actually other avenues for the hacker to get in as well, including this Oracle O executable. And by the way, look at that. Look at the executable there. RWS, RS, and X, exactly like the previous Oracle thing. So what do? Should you remove it? No, because if you remove it, there's going to be a problem with it. If something goes wrong in the relink process, you can't restore the backup. So what you do is, simple thing, find those first, like this way, then just make them CHO, not really thing, 0000. And actually, so I apologize for this one. It should be CH1, it should be chmod 0000. By doing so, nobody will be able to execute anything. They can't see the file, they can write to the file, of course, they can't execute the file. They can't see the file, so I'll figure out execution part of it. That should protect you from all kinds of the vulnerability issues right there. There are other examples as well, like DBSNMP. That DBSNMP was initially used for Oracle Enterprise Manager, but look at that, the owner of that. The owner is root. Do you see that? It's root. Root means now it can actually execute. And by the way, just look at the S in the permission thing as well. That's called set user ID. That means it allows certain functions to be given as root, including a lot of malicious commands as well. So it's just obviously much, much worse than what it looks like here. So what you have to do is simply make them first chown, that is change the ownership from root to Oracle, and then make it 0700. Same thing also goes with listener control and listener 0 and all that thing. A listener control by default has execute privilege for the group and execute privilege for the outside world as well. Well, why? Have you ever thought of anybody executing listener control except the DBA group? No. In fact, I would suggest why with DBA group? If you want to scatter the listener and shut down the listener, just become Oracle using the sudo command I showed earlier. Sudo su -Oracle listener control start. Listener control stop. Anything you do, that will make sure that nobody should be allowed to execute listener control except the Oracle software owner. And by using the sudo command, you're actually creating audit trail of all that. So this is what you should do. chmod 700. That means only Oracle can do all these things. Nobody else, including the DBA group, can do anything to the listener or TLS listener. Configuration parameters. Look at the listener Aura file. It has an execute privilege as well. Remove it. No need to have read and execute privilege to listener Aura file. It can be made visible to everybody else. But if you use clients and running in the same box, then you should not be changing the SQL Aura and listener Aura file. But remember one thing I mentioned, one of my best practices I mentioned earlier, is that separate the client Oracle home to a different Oracle home. Well, if you do that, you don't have to worry about this one. That SQL Aura. You can change that completely. External procedures. Go and check in your listener Aura file. I bet you can probably find this thing called protocol IPC key equal to external procedure. What does it do? What it does is, if you're using an external procedure, you can actually make an operating system call directly from a PLSQL procedure. Let me repeat that. You can actually make an OS call, for example, MV command, the CP command, FTP command, all kinds of commands that you can do with the Unix command line. You can do that directly from a PLSQL procedure. What's the bad thing about that? When you do from a PLSQL procedure, when you make an OS command, you are not running under the context of Oracle database anymore. Now you're running under the context of the Unix operating system. When that happens, which user actually executes that? Well, think about it. Which user actually runs the Oracle database kernel? Is the Oracle software owner. Perhaps it's Oracle. So when you give an external procedure or external job, what happens? It actually gives the command to the Unix operating system to be run as an Oracle owner. Now see a problem here? That's exactly what the hackers use. They send harmful commands to the external procedure to be executed directly by the Oracle owner, including shutting down the system, removing the files, corrupting files, and all that thing. So do you use external procedures? I can bet you you're not. But I can bet you that your listener Aura file does contain this. So the first thing you should do, remove all this. Remove the external procedure. If you're using it, fine, but if you're not using it, completely remove it. By default, it's there. What if you do use it? Well, then I suggest you actually separate the listener into two different listeners, or listener Aura file. So in this case, the default listener doesn't have any external procedure. There's another listener in this case. I call that listener_exp proc. That has the external procedure name, and let that run the external procedure. Why? Because if you suspect an attack is going on, or if you suspect somebody is exploiting the external procedure, you can shut down that specific listener without shutting down the other listener. That's why. That's why it's always a good idea to separate the listener. And by the way, you can have as many listeners as you want. There's no restriction that you must run only one listener. As long as the listeners have different port numbers and all that, you should be fine. So in this case, that's exactly what we're doing. Port numbers are different, and you're running a listener process. Okay, let's go to the next one, hiding passwords. How do you hide a password? Many folks actually do this. The skill class, Scott, Tiger, at some MyScript. MyScript is a script actually you put here on myscript.sql. That's where you put all your SQL commands and you execute this as a batch process. What's the problem? Some people feel, well, then I can do a ps-ef command. I can find out the Scott's user ID and password. That's a good idea. So some people got creative, and instead of putting a password of the Scott right there, they put the password into a variable and put Scott $pass. And they feel that's not, it's not possible for anybody else to find out. Not true. What's the problem is you can do some PS commands, and then you can actually do some options in PS. I forgot exactly what it is. I think it's called W or X. That actually can show all the environmental variables that do the process. And in that environment variable, you will find out the variable, the value of the variable Scott pass. And in that, what you do is, so then how do you make sure that nobody else can see the password of Scott? Option 1, you use SQL class no-log. If you have not used the no-log, what no-log does it doesn't expect a user ID password to be stored. So you say SQL class / no-log MyScript. In that case, a SQL class session is open, but no connection is actually made to the database itself. Inside that, it actually puts connect Scott Tiger. So your file, myscript.sql, contains the words connect Scott Tiger. As a result, somebody doing ps-ef will not be able to see the password. In fact, only able to see even what user ID is connected to. It will simply see SQL class no log. That's it. Nothing more than that. Option 2, you can put EOF command, SQL class no log less than sign EOF, and connect Scott Tiger and put everything before the EOF command. That's also possible. You can do that as well. But the better option is that you can create something called passwords file. So this is what I generally do. I create a password file called .passwords. Again, .password is important. And in that, I put things like this: Scott space Tiger, Arup space Arup, all the user IDs and the passwords next to each other in a file. Then I created a shell script called .getPass.sh. And the shell script is very simple. This is the only line in the shell script. fgrep $1, and you can see the whole thing here. So what it does is, if I pass a variable to that, it checks the first column of the file, and if it matches, it returns the second field, which is the password field in this. So this is how I use it. I use .getPass.sh Scott. And when I do that, it returns the password of Scott, which is Tiger in the file, and then I pass it into SQL class -s Scott and all that. Okay, in that case, nobody can. If somebody does a ps-ef, they will actually see two different processes. One is called getPass.sh and SQL class. They will not see what value was passed. How does it help? It not only helps in hiding the password, it also helps in managing passwords as well. So all my scripts, I don't have to put the passwords at all. I can simply create a single password file and use that for all my processes. And also, you might have noticed one thing here. I use the dot before that and the why dot? The dot actually hides it. Unless somebody does ls-la, if you do a simple ls-l, you will not see the files that start with dot. So by putting this dot passwords and .getPass.sh, I kind of hide from the casual onlooker. And somebody has to actually specifically look for it to find it. It's a simple mechanism. Okay. Again, I actually started very late, so actually it's beyond 6 o'clock. So Francisco, should I continue or should I stop right here? Francisco? Okay, so maybe.
Arup, can you hear me?
Yeah, I can.
Okay, yes, you can continue. You still have 8 more minutes.
Oh, okay, perfect.
Thank you.
All right. So next one goes is other options. So what else can I do? I can do DBMS job. I can do a DBMS scheduler. I can also use ops accounts. So if you have used ops accounts, you probably know this already. You can create user OPS $Scott identified externally. What it does, it doesn't require a password. The authentication is done by the OS and not by the server itself, not by the database server itself. Then you can simply put SQL+/. Many folks tend to think that that password is not, and this OPS account is not secure. Well, there is no reason to be insecure. This is a very simple thing. Now, unless the OS authentication is weak, there is no security risk in this at all. But if OS authentication is weak, then you have a bigger problem. Then anybody can log in as Oracle user and all other users, then you have a much bigger problem to worry about and not this one. So this is important that you can also use ops accounts. In RMAN, you can create target equal to /. In the example is, you can also, generally people put this way, RMAN target equal to / RCV cat user ID password at cat.db. Not a good idea, because then somebody can do a ps-af grep in the command line and get the user ID and the password for the RMAN catalog user. Instead, what you should do is RMAN target equal to /. Inside the RMAN script, you do connect catalog user ID password. Okay, the default password. This is interesting. How does Oracle actually store the user ID and password? The table user $, and also the DB_user, they contain the user ID and the password. Well, it can't be that simple, because if the user ID password is stored in such a clear manner, anybody can go and actually grab it. So what Oracle does, it actually encrypts the password. But that's exactly where the problem lies. What they do is, they don't encrypt the password. They actually combine the user ID and the password and encrypt that one. So here's an example of that. It's a user ID ABC, the password is DF. And another user ID is ABCD, and the password is EF. They're actually different passwords. But what Oracle does is it combines it. So in this case, ABCDDEF, all will be combined into one, and the encryption will be generated. So the password has stored in the user $ table is actually this way. It's stored as, both values will be same. So what's the problem? The problem is, I can guess now what the password is. Because what I have to do is, I can create, let's say, if I have to check, is the password of Scott Tiger? All I have to do is actually create, well, I can't create a user ID called Scott, because the Scott is already there. So all I have to do, I can create a user ID called Scott T. I'm sorry, Scott is SCOTT, another T, there have been 3 T's, and the password is Iger. So the user ID is SCOTTT, and the password is IGER, and the password, if this is created, the password has to be exactly similar to the Scott's password has as well. Then I know at that moment that the password of Scott is Tiger. That's how hackers typically do it. So this is also, we can use the same thing to create to understand the default passwords. So instead of doing all those things, what I have done, there's a gentleman called Pete Finnegan. He lives in the United Kingdom, and he actually put a lot of research into that, and he's put together a default password of many users, and they're put into the website. So I've given the website name here at the public script. What I do is, you can download this his script, create this table called OSP accounts, load his script, and it will populate the tables completely. And then I have written a very simple process. You can in the last one called the get def password at SQL. That actually shows you what are the different default passwords. For example, Scott Tiger, sys change on install, system manager, all those, or SH, all that thing. You will find out all the default accounts, and you should be able to change that very, very quickly. In 11G, actually, it's very simple. There's a view already called DBA users with the def PWD. You can just check that, and you can download, you can create, select from that, and you can get that very, very quickly. 11G. Trim privileges. This is a very, very interesting thing. Generally, when you create some privileges, some people come to the DBA and say, hey, I want some access to database. What kind of access? Oh, we don't know yet. Just give us any table privilege. So I don't know exactly what it will do, so just give me all kinds of privileges. And this is exactly where the problem comes in. If you have a create any table, create any procedure, create any index, it actually doesn't let you create on your own schema. It actually creates, allows you to create tables, indexes, procedures in other schemas. Let me repeat that. Create any table allows you to create a table in a different schema, not necessarily your schema. And what different schema? Including sys and system schema. So can you see that now? It becomes a huge problem because some user can actually create some sys schema, although may not be intense now, maybe accidental, but they create it and eventually fill up the system table space. It will probably fail. Same thing also goes for restricted session. Select any table privilege, select any dictionary privilege, unlimited table space. You can fill up a table space and bring the database to its needs. So how do you find it? It's a I call sweeping privileges. Very simple to find out. I have a script, I put it there, sweeping.sql, and you can actually download it, run it, and find out who are the sweeping privileges. Seemingly innocuous privileges. Let me give you a quiz at you, and I'm not expecting an answer. I'll just give you an answer afterwards. Scott is a user. Scott does things like set query rewrite enabled, alter session set optimizer mode, alter session set sort area size, all those things. This is something Scott does as a regular basis in the application design process. Do I need to give Scott alter session privilege? No. Answer is no. It might not sound right, but actually I don't need to. Scott does not need alter session privilege to execute the command. Wait a minute. In that case, what is the alter session used for? Alter session is used for only if you do an I/O. For example, if you do alter session to create a trace file, alter session set SQL trace equal to true. Only in that case, you will need alter session privilege. So why is that a problem? Problem is, you can use alter session to create a lot of trace files, which will eventually flood the database server. You haven't touched the database server at all, but by simply creating these alter session privileges, you actually flood the trace files, number one. Number two, it's possible sometimes, in some vulnerabilities, you can dump the content of library cache or set or something into a trace file and get that from there. So, you should remove the alter session privilege. A typical user might still give the set query enable, set optimizer mode, set the sort of and all that. He will not need alter session privilege, so revoke it. How do you know who has it? I have a script for that called alter session guarantees.sql. Run it, you can find out who has it. Other dangerous privileges, create any directory. Well, you can create any directory as an Oracle or owned by Oracle user, including data files. Once you create any directory, if you have the F open, you can open any file and open and read any file, write any file, including data files. So you should never give anybody create any directory privilege. They can simply create directory on their own object. Actually, the best thing I can do is that the system or sys, you create the directory, the DBA create the directories only and gives to the users. So users never have any directory privilege. Users never create directories. Users always use the directories created by system earlier, which is important. Same thing goes for create any trigger. Create any trigger allows you to create a schema and it triggers any schema to capture sensitive data during insert update. So not do that. Create database link in the same way. So even if you don't have access to the other database, you can still create database link because if your user ID is matching on both sides, you can create database link using the connect string. You don't have to give a password, which is a problem. Dangerous supplied packages. This is another problem here. Here's the thing, UTL TCP. Have you used it ever? I bet you haven't, because this is something you probably have to do. What does it do? It actually allows you to connect to a different server on the TCP IP level using the 1521 port, or on the port the listener is listening to, but the TCP IP connection. So this was designed initially as a convenience so that people can connect from one machine to the machine at the TCP level and get something. But you see the problem here. The problem is database servers, they have to open to the listener port. They have to let the other people know which port they are listening on. And UTL TCP actually use that entry to get access to the OS and do a lot of damage. Remember the Voyager 1 about 4 years ago that actually caused a lot of problems because that actually was a worm that went over Oracle databases and brought down into his knees? That actually, this is how they did. In a system, in a typical data center, you probably have the ports open, and what the Voyager did is that once it went to a little bit less secure database, From there, it went to other databases using UTL TCP. So what's the problem? The problem is you don't even use UTL TCP in many cases. But the problem is it's actually granted to public by default, which is, by the way, fixed in many other versions after Oracle. In 10G, it is still granted to public. And therefore, anybody can actually execute it, even though you don't need it. So revoke this. It sounds very benign. Sounds like, hey, it's harmless, UTL TCP. No, it's extremely dangerous. So you revoke the privilege from public. If anybody wants it, you grant to that person directly, but never to public. So it's for DBMS scheduler, DBMS Java, UTL file. And the last one is very, very important, DBMS assert. This is a very difficult thing. What DBMS assert does is it actually checks if the SQL statement is okay or not. But the problem is, most cases, in some cases earlier, hackers actually used it to mount an attack on the database. And that was the biggest problem in the DBMS assert. Though they are dangerous supplied packages, and you should make sure that it's removed from public role. Francisco, should I stop or should I continue?
Arup, if you still have time, you can keep going.
Oh, wonderful. Thank you. So I have time. I know I started late, so just let me know if you have some thing. Just let me know. I will stop.
Thank you.
Okay. Access control for packages. In 11G, however, we have actually another wonderful feature called access control list. So what if you actually need UTL TCP? Well, in that case, you have to grant it to the user. Problem is, once you grant the UTL TCP, you can actually connect to any database as long as the IP address is there. You can connect to anything really. How do you make sure that you connect to a specific server only and nothing else? You can do that using this thing. This is a simple thing I put together here. The first one is called network admin, SCL admin, create SCL, add the privilege, and you say assign SCL. So in the final stage, what I'm saying is that I cannot connect to any other server except the server www.proligens.com. And I can't connect to any port other than between 22 and 55. So this allows me, I can still use TCP, but all I can do is connect to www.proligens.com and the port number between 22 and 55 and not before and not after that. So even if I have access to UTL TCP, it still doesn't let me do any damage because I can't do any damage to any of the system. So if you're in 11G, you should definitely use this. First of all, so rule number one, if you are not using UTL TCP, revoke the privilege from public. If you are using it, grant it to the user. If you are in 11G, create an access control list. And the result, you will solidify that the database vulnerability completely and nobody can do anything about it. UTL file DIR. What's the problem? Check if it's set to asterisk. Why asterisk, by the way? Well, what UTL file DIR does is it's a parameter in the Aurora file. What it does it lets you open the files in a specific directory, OS directory. Only if it is defined in that. The problem is, many DBAs probably did not know earlier which files the developer will write to. So they simply put an asterisk there, and this parameter is not dynamic. And therefore, to change the parameter, they had to bounce the box. So they just put asterisk there because they had to bounce the box. Bounce the database, they didn't have to do anything with that. Problem is, once it is asterisk, any directory that is writable by Oracle can be written by the developer. They can simply use that, UTL file open, fopen, and then directly is possible. Huge problem. Why? The hacker can actually get in, write a simple program, fopen a database file. Worse, write a database file with junk. Big problem. So what you should do? Very simple. You simply do a something called a create directory, which is the new object in 9.9 will introduce. So first you create a directory, let's say called mydir as U01 mydir. Then say UTL file open. Instead of putting a specific file name there, you put a directory object there. And this is called mydir myfile.txt.w. So they can always create files, they can drop files, all that, but only in that directory. And never asterisk. LAOUC, however, requires ETL file dir. So to do that, what I generally do, I just put ETL file dir and put /tmp. Why /tmp? Well, that's for the minimal file people can have. Most likely it doesn't have any specific files of any value, and putting /tmp there doesn't actually add to the problems. So I just generally put /tmp there and leave it because LAOUC I still want something. And that requires a database restart. But never, ever set it to asterisk. Indirect grants. Let's say I have a user called John. John has a table called tab 1. Now, John grants select on tab 1 to Mary, another user. But here is a kicker. He gives a grant to Mary as grant select on tab 1 to Mary with grant option. What does it do? Which grant option allows Mary to grant it to another user called Andy. Remember, this table is owned by John, but Andy has the select privilege in it, but not directly from John. He got it through Mary. So John grants it to Mary with the grant option. Mary grants it to Andy, and then that cycle continues. And if Mary grants it to Andy with a grant option, Andy can also grant it to another person, and so on and so forth. What's the problem? The problem is, what will happen to Andy if Mary is dropped? You said drop user Mary. Shouldn't that be something interesting to think about? Well, it's not very logical. Here's the problem. Actually, in Oracle, what will happen depends on what kind of privileges are given. In case of system privileges, for example, in this case, it's grant, create trigger, create table, create procedure, and all that, which is called with admin option. With object privileges, is called with grant option. This is a little difference. So system privileges are granted with admin option, and object privileges are granted with the grant option. And that's how the other people, the grantees can grant it to other people as well. The problem is, if the Mary grants its object and Mary itself is dropped, then Andy will lose the object privilege, but will retain the system privilege. So in this example, in this example, once Mary is dropped, Andy will lose the access. Is that a problem? Absolutely. How do you know Andy? Once Andy loses access to the system, all the systems, all the procedures Andy developed, they're probably gone. Or Andy's programs will not run anymore. Or the systems that used Andy's user ID will not run anymore. It's a problem in return. But it's the worst problem. If there is a system privilege granted by Mary to Andy, they will continue forever. So if you think that by dropping Mary, you are severing all connections Mary had in the past, not going to happen. Object, yes. System privileges, no. Therefore, we always recommend never to give this indirect grants. Never. So how do you find out? You find out this indirect grants using this command. Select grantee privilege and all that. Again, don't worry about that. I have a script for that as well, naturally. So I identify the grantable privileges and the granted privileges, and then I get all that, and then I revoke the privileges from the grantee and grant it directly from the owner. Actually, I have one more suggestion for you. What I do is that we have something called schema objects. And schemas. Schemas are never connected directly. For example, SH schema, OE schema, business users. The schemas are never, they're not human users, they're actually schema. All they do is content tables, views, procedures, and all that. They are never allowed to be connected directly to the database. So when we alter a table, we actually log in as a regular user who has the privilege to alter the table and alter the table. Why? Because that way we keep on auditing who exactly did it, not by somebody else. In this example, however, how do you know that, how do you grant, so in this example, for example, John is not a human user, suppose. It's a schema owner. So since we don't allow anybody to connect as John, how do we grant the access from tab 1 directly to Andy? Well, very simple. Become a sys user or a system user and allow that access directly from John to Andy. So you'll say grant select on John.tab1 to Andy. Very simple. There's no indirect at all. Simple logic. Now, as you know, this is always the best practice. I always put audit trail to DB extended or DB based on that, or at least DB. Even if you do not want audit anything yet. So repeat that. Even if you do not want auditing yet, I still put audit trail equal to DB extended or DB. Why? Why? Because, first of all, the objective is that do a simple audit. Simple audit is just audit session. What it does is, when you connect, a record is created and nothing else is done. When you disconnect, that record is updated with the data. What kind of data? Well, we'll see. First of all, let me understand that. Session auditing, only one record gets created and same record gets updated when the session disconnects. Anything happens in between, nothing gets updated in the system, audit trail itself. So the impact is very, very less. Let me see the chat window or something here. Okay. So how do you do that? Once you have session auditing, which is done in this case, simply do this. Select all these commands you have here and that from DB audit trail, which shows you what OS user, what terminal they came from, the time of login and log out. So here is a simple example of that. Suppose somebody said, who tried to log in but wasn't successful. It's important. So in this case, whoever tried to log in but wasn't successful, they would have got this Aura 1017 invalid user ID and password. If you see a lot of this, what do you think is going to happen? Well, probably they genuinely forgot the password. That's possible. But what if somebody was trying to break into or guess the password? Well, you will be able to find it out right away. So you see the person X has actually tried 5 times. And from what exactly OS user ID or what terminal? So if you see the John Smith, somebody was trying to log into John Smith Oracle account, but the OS user ID doesn't look like John Smith. That means either John Smith went to somebody's machine and did that, or somebody was trying to use John Smith ID and try to guess the password. Well, in either case, it's going to be a security violation. You should tell John Smith that somebody is trying to do it. By doing so, you can easily do that. Very, very simple. In a normal situation, you will not see any record with 1017. Only if you would forget. But if you do see, it will be easy to figure it out. Very simple. Actually worse. What if somebody is trying to guess the user ID? This is a typical hacker trick. Hackers typically try to guess the user ID, so nobody actually uses what they're there. For example, Scott. Scott is a demo user ID. You may have created that in the first the database was built, but you have forgotten to drop it. And if you drop it, most people don't even realize that, hey, the Scott is probably there and it's not doing harm, let's just leave it there. But that could be a way of entry of hackers. So hackers try to connect as Scott, but Scott isn't there. But they will get the same response, which is Aura 1017, invalid user ID and password. Oracle doesn't tell them if the user ID is wrong or the password is wrong, or both. It doesn't tell them that. It simply tells them that the same user ID. But from your perspective, you can do a simple command like that. Select username from the audit trail of the written code equal to 1017. You do a minus and username from DB users. Boom, you just found out. We found out who is trying to use their wrong username. Which could be, by the way, very simple. For example, somebody might be trying to connect as, let's say, J. Smith, but had a typo. So instead of JSMITH, he might just put JSMIT. Boom, that's the wrong user ID. That could be a simple, genuine mistake. But if somebody tries to log in as SES, as Scott, or SH, or BI, or something, you know somebody's trying to guess the user ID. And you know exactly which OS user ID it came from, which terminal it came from, if it is a laptop, which one it came from. You can go and track down the person and tell them, hey, I'm watching you. What else you can do with that? You can also think as well. You can also do CPU and IA usage as well. Simple thing. Another simple command I gave you here. It shows me what are the different usernames, what time do they usually connect, what day and thing, and how many sessions they usually have, how much CPU is consumed, average CPU consumed by the session, how much total CPU by the new session, what is the minimum and maximum and all that. This one tells me a lot of things. This one tells me it helps you prepare a profile of application. So if I store the data for some time, I'll probably see that user ID called user1, let's say, has about 1,000 sessions every day. And they consume about 10,000 CPU cycles or something like that. So it helps me. What if I see a large jump in the session count, like 2,000? It's a problem, because then I have to think about capacity. This is a typical problem DBAs have. Somebody comes to you and says, hey, do you think we can sustain another, if you double our application, do you think we'll be able to sustain it? So how will you address the question? You are going to, unless you know exactly how much they're consuming, it's impossible to do that. Well, in this case, you do. The question you'll ask them is, which application are you trying to double? For application user 1. All right? And that consumes about 10% of CPU. So if you double it, yeah, it's 20%. Not a bad idea. What if, no, not application 1, application 2, which is consuming 50%? Well, there is a problem. And I can't make it double and sustain the capacity. We have to augment the capacity. This is important. All right? So I'll just skip this part real quick, auditing use. So this is what I used to do. I always put the initialization parameter audit trail DB extended, and I start with DB session, by session. Once I find something, I go deeper to divide access. So in either case, I can find out who can do that using this SYSDBA master by who is using that and who is using the specialized tables, which is important. Control schema change, which is probably very important. You might have seen that. Here's the problem. You have a schema called ACNAM. There's a main schema, account manager, suppose. And the password is known to the application group. That app is the user ID that connected to the database. That's application user ID. How will you make sure that the DDL changes are in tune with the change management process? Typically, in most companies, you have a change management process. You ask for a change window is given to you. You make the change. At the end of the change, you say, okay, change is done. But how will you ensure that the people making the change are doing the change in the change window only and not before or not after? Since the application people, they control the schema, they can always go and change it. You can't say, revoke select privilege from the application owner. The owner can do anything. The owner can insert, update, delete, alter, all that. You cannot revoke, alter privileges from the owner itself. So how do you do it? Here's a simple solution. What if we had something like this? A release manager, the change control manager, unlocks something. We don't know what something yet. Unlocks something. The RDB or the developer makes a DDL change. After that, the release manager locks it again. No DDL allowed. So unless the release manager unlocks that something, the app people cannot make the DDL change, even if they are the owner. That's an interesting thought. How do we enforce it? Let's see. It's a simple thing. I can do that using a simple DDL trigger. Create a replace trigger, lock, alter, simple DDL trigger. It says the thing. If the dictionary object name is this important procedure and ORA event is great, it will raise an application error. -2001 can't alter object name. That's it. Once this trigger is in place, even if you are the application owner, even if you are the owner of the object, you still can't alter the table, alter the procedure, simply because you will get the error all the time. And because this is not owned by you, the trigger is owned by sys or somebody else. So you can't even disable that trigger to go around it. So this is the process. This is the locking and unlocking process. So when the change window approaches, the release manager goes and disables the trigger. The trigger is disabled. You, as an owner, you can do the alter procedure, create and replace procedure, and then the release manager comes in and enables the trigger one more time. And that is effectively locking it. Very, very simple. Listener log monitoring. Listener log has a wealth of information, but is not usually used. So I can't go into that because there's a lot of details, but if you go to my blog, I actually given a detailed example of how you can use an external table to read the listener logs and information from it, which is very, very important. And it should definitely, I have a lot of examples there to show you how to do that stuff. I'll skip it right here. So in conclusion, let's see how in one single day, what you can accomplish. All these things you can do in a single day. You don't take more than a few minutes up to a max of an hour for each one of them. So start with that. Make the listener changes. You do a reload listener to take effect. Remember, reload is not the same as stopping and starting. So there's no outage. Reload is simply loading everything for listener. Make all the non-required binary changes, which is not important part. Then you make all the binary permission changes that we mentioned earlier. Oracle should be 700. Oracle 0 should be 000, and those kind of things. You do all that. Make the changes to the error parameter. And then, take some time and recycle the database. Then, enable the auditing we mentioned earlier. Remove the sweeping privileges. Remove the execute privileges from the public from the procedures we just discovered, like UTL TCP and UTL scheduler and all that. And then, at the end, you will have accomplished about 60% of the goal of compliance. Again, 60%. 1 day's worth of work, 60%. Not bad at all. That's the beauty of it. So it's not difficult to actually create a security plan, but actually a much better one. Actually, I have a course called Securing Oracle Databases, 2-day course. This is an adaptation of that. This is something I enjoy giving people, is because people they will think it's very difficult to secure Oracle database, or it's not difficult. Time-consuming and expensive and all that, not true. You can do simple things like this, as I mentioned here, and you can accomplish a lot just by doing simple things. So with that, thank you very much, and I will open up for questions. And for the people who dropped up earlier, here's a blog address. You can download all the scripts I mentioned over here from the website and from the website I mentioned over here. So with that, I'll open for questions.
Hi, Arup. Thank you so much. Excellent presentation, like always. I have one question from Eduardo Hans from Oracle User Group in Brazil. And also I want to tell you that some users, inclusive in Ecuador, joined to listen and watch your presentation together. And the question I have from Eduardo is, which the main safety points in version 11G release 2 in your opinion?
Okay. First, I address that right. So there are few safety improvements in 11GR2. First, actually, I'm going to set up an article on 11GR2 new features, just like my previous one, 10G features and 11G features and all that. So it's going to come out very soon. The first one I can see is that the access control list has been improved significantly. You don't have access to the case-sensitive passwords. Now you can, by default, you have that case-sensitive passwords, and you have now execute directory privilege, which is very important. Earlier, you didn't have that. You had, if you have access to the directory, you can read, write, and on the directory all the way. Now you have actually execute privilege, so you can actually give people to execute certain utilities in the directory and not give everything else. And another one goes with that thing. You also have an execute audit, so you can also find out who are actually using those utilities in the directory itself and execute. So those are the few things in security.
Thank you so much, Arup. And let me just check. Yes, no more questions coming. Basically, that's it. And Arup, thanks so much for all your support you give all the time to Oracle user groups around the world. And this is the first of 4 webcasts we have programmed with you. And one more time, thank you for that. And sorry about the technical problems when we started the webinar. Just learning how to use the tool, but now I learned where is my mute in this system.
Okay. So thank you very much, Francisco, for inviting me. I really appreciate that. I feel honored to be the first webcast speaker for Latin America Oracle User Group.
And New Zealand Oracle User Group too. Mm-hmm. Thank you so much, and hope to see you soon.
Thank you.
Okay, bye-bye.
For DBIS, Database Integrated Solutions,
They are the Platinum partners with NZOG and Platinum partners with LAOUC. Thanks to them, we are using these webinar tools and basically transmitting this for everyone. Thank you, everyone, and I hope to see you guys again in the next webinars.